All right, so my next goal is to find the intervals where it's increasing and decreasing. So to do that, I think it would help if I knew what the fifth root of negative 1/4 was approximately. And if I put that into a calculator, I would get negative 0.76. So the reason this is helpful to me is because I need to pick a point on the left and on the right of the fifth root of negative 1/4. So now I know some numbers, now that I have it as a decimal or an approximation. I know that f prime of negative 1 would be on the left. And I also need to remember that 0 is not in the domain, so there's a break there. Let's see, so I could also do negative 1/2. And then I need something over here like a 1. Over here on the right. So I will plug those in with a calculator to, let's see, this function, the derivative was 4t cubed plus 1 over t squared. 4t cubed plus 1 over t squared. All right, but I am plugging in for all of those t's about negative 0.76. Oh, no, my bad. Negative 1. So actually, I think I can do some mental math here. Negative 1 cubed is negative 1. Times 4 is negative 4. And then negative 1 squared is 1, so plus 1. Get negative 3. So it's decreasing over here. And then 4, and then to the negative 1/2. 4 times negative 1/2 to the third power plus 1 over, I can already tell I'm going to need a calculator for this. Okay, if I put that into a calculator, I would get 3.5. It's interesting. Okay, so I get something positive here. And if I plug in 1, this should be a little bit easier. 4 times 1 cubed plus 1 over 1 squared. 4 plus 1, I get 5. So something positive there. So with that, I can write my intervals of increase and intervals of decrease. It's increasing from the fifth root of negative 1/4 to 0, and decreasing from negative, oh, I almost forgot, and then on from 0 to infinity. So it's decreasing from negative infinity to the fifth root of negative 1/4. Boom. Okay, let's move on over to the right and work on the intervals of concavity. So just like before, I need to remember where 0 is on my number line because it's broken up there as well. And I can pick, well, let's approximate this. The fifth root of 1/6 approximated is, the root of 1/6 is 0.73. Ish, close enough. Okay, so in my second derivative, I can plug in negative 1 for this interval. And then I could plug in 1/2 for the middle interval and 1 for the outside interval. And I'm plugging it into 12t squared minus 2 over t cubed. So 12 negative 1 squared And let's see, what was the rest of that? Minus 2 over t cubed. Minus 2 over negative 1 cubed. Okay, so negative 1 squared, I just get a 12. And then negative 1 cubed is still negative. So I think I end up with 14. So I'd say positive here. And then for 0.5, I'm just going to have to put that into a calculator. If I plug in 0.5, I get negative 13. And plugging in 1, 12 times 1 squared minus 2 over 1 cubed. I'm going to bet that's 10. Yeah, 12 minus 2 is 10. So I get something positive. So I can write down where it's concave up. Negative infinity to 0. And I'm just looking at my number line here. And then the 5th root of 1/6 all the way to infinity. And it's down from 0 to the 5th root of 1/6. Cool. So actually I have a lot of information here. I have where it's increasing and decreasing. I have concave up and concave down. I have an x-intercept. And I also know that it's a rational function. So let's actually pause here in case there are questions, and we'll come back later.